When Charles Darwin gave us his theory of evolution, it was all built around one powerful idea: survival of the fittest. But there was this one little, well, actually big, thing in nature that just didn't add up. A beautiful, extravagant, and kind of dangerous puzzle that threatened to unravel his entire theory. Today, we're going to dive into that puzzle and uncover a pretty surprising twist in how science has been telling that story ever since.
Just look at a peacock's tail. It's absolutely a masterpiece. But it's also a giant, shimmering, "Hey predators, come eat me" sign. It's heavy, it takes a ton of energy to grow, and it makes getting away from danger tricky. From a pure survival point of view, it makes zero sense. And this exact problem basically drove Darwin nuts.
You can just feel his frustration in this quote, can't you? For Darwin, this wasn't some tiny little exception to the rule. It was a glaring problem that seemed to defy the very core of natural selection. If survival was the only game in town, the peacock should have been an evolutionary dead end. But obviously it wasn't. So to solve his peacock problem, Darwin had to come up with a whole other force of evolution. And his solution was brilliant. He basically split selection in two. You've got natural selection, which is all about adapting to your environment so you can survive, but then you've got sexual selection, which is all about adapting to the social world so you can reproduce. See, it's not just about staying alive, it's about passing on your genes. That peacock's tail isn't for fighting off tigers, it's for winning over the ladies.
Okay, so how does this second force, sexual selection, actually work? Well, for decades, biology has been telling a pretty consistent story, one that really focuses on two main things: competition and choice. Let's break down that classic textbook version of the story.
At its heart, the definition is pretty simple. It's basically any trait that gives you an edge in the mating game. This could be something really obvious, like two massive stags locking antlers, or it could be much more subtle, like a female bird picking the male with the absolute brightest, most colorful feathers.
So when a female is doing the choosing, what's she actually looking for? Well, biologists usually lump the benefits into two big categories. First, you have the direct benefits. These are the straightforward, practical things: a good territory, protection from harm. Maybe he brings her food. But it gets really interesting with the indirect benefits. This is when she's choosing a mate based on the quality of the genes he's going to pass down to her kid.
And this leads to one of the wildest ideas in all of evolution: the sexy son hypothesis. It's this incredible feedback loop. Just imagine, for whatever reason, some females start to prefer males with slightly longer tails. Well, their sons will likely inherit those longer tails, and their daughters will inherit the preference for them. So now the long-tailed sons get more mates and the trait spreads. But the preference also spreads because the females who have it end up with, you guessed it, sexy sons. It's a self-reinforcing cycle that can just spiral into total extravagance.
The other big theory is the good genes hypothesis. And here, that fancy tail isn't just for show, it's an honest advertisement. The logic goes like this: only a truly healthy, genetically superior male can afford the cost, the energy, the danger of producing such an incredible ornament. So that tail is actually a reliable signal of his top-notch genes, which promises healthier, tougher offspring. And you should know, this isn't just some fun guesswork. Scientists use these incredibly complex mathematical models to simulate how these traits and preferences can actually evolve together over thousands and thousands of generations. These models are the rigorous scientific backbone for the whole theory of sexual selection.
But what if it's not the whole story? The story we've just laid out is powerful. It explains a lot, and it's been the foundation of the field for a long time. But what if the way we've been telling it has left out a massive piece of the puzzle? What if the science itself has been looking at the world with one eye closed?
Think about it. Sexual selection is an interaction, right? A dance between the sexes. But what if the scientific spotlight has been shining almost exclusively on just one of the dancers? Well, a growing body of research suggests that for a very long time, that's exactly what's been happening.
And the data here is, well, it's pretty startling. In 1970, the theory of sperm competition, a totally male-centric idea, was introduced. The female equivalent, cryptic female choice, didn't really get attention for years. But just look at the research focus since then. Over 5,000 publications on the male theory compared to just over 700 for the female one. That is a massive, massive disparity.
And it's not just an isolated case. This chart shows the wider focus of sexual selection studies in general. And yep, the pattern is exactly the same. The overwhelming majority of research has been focused on males, on male competition, male traits, and male strategies.
This pattern actually has a name. Researchers call it male precedence. It's this tendency for the science of males to come first, sometimes decades before the equivalent ideas about females are even seriously considered. It's a pretty stark reminder that the questions science asks can often reflect the perspectives of the people asking them. And for a long time, that's meant the story of sexual selection has been fundamentally incomplete.
So what are the real consequences of this male precedence? What exactly have we been missing by focusing so heavily on one side of the evolutionary equation? Let's look at a couple of really powerful examples of what's been left in the shadows.
Let's go back to sperm competition. The idea that males compete after mating was a huge deal in 1970. But the equally mind-blowing idea that females might have some say in the matter after mating, that took years longer to even be formulated. And as we just saw, it's gotten a tiny fraction of the attention. It's like we spent decades studying the runners in a race, but for a long time we almost completely ignored the racetrack and the judge.
Now this is where it gets really revealing, how the exact same behavior gets explained differently depending on who's doing it. So, when a new male lion takes over a pride and kills the cubs, it's framed as a classic sexual selection strategy, right? He's getting rid of his rival's offspring so the females will be ready to mate with him. But when females commit infanticide, it's very often explained away through the lens of natural selection. Oh, they're just competing for food or nesting sites. The possibility that it's also a form of reproductive competition is often completely missed.
And you see, this bias isn't just about which animals we decide to study. It's baked right into the very definitions we use. The way we framed sexual selection from the beginning has, probably without meaning to, just excluded a huge range of female behaviors from the get-go.
It all comes down to how we define sexual selection, which is usually competition for mates and fertilizations. Now that works perfectly for all the behaviors you see on the left. But what about the column on the right? Things like females fighting over the best nesting territory or competing for resources to raise their young. These are incredibly intense forms of reproductive competition, but they often fall outside that narrow definition and just get called something else entirely.
So how do we fix this? Well, some scientists are proposing we broaden the whole framework to something called social selection. This is a much more inclusive idea. It's about success in any social competition that affects who has more or better offspring. So under this bigger umbrella, the classic sexual selection we've been talking about is just one part of the picture, and it finally makes room for all those other types of competition that have been ignored for so long.
And this really brings us to the big final thought. This journey through Darwin's dangerous idea isn't just about peacocks and scientific history. It's a really powerful reminder that science is a story told by people, and the perspectives of those people can't help but shape what questions get asked and what truths get discovered. And it leaves us with a pretty critical question to chew on. If a bias like this could shape a field as fundamental as biology for over a century, what other stories, in what other fields, are we still only hearing one half of?